Our next presenter is going to be telling us about how big data helps secure cloud servers. Igor Seletsky is the CEO and co-founder of Cloudlinux. He created the company in 2009. It's based in California, and he now has a global business. And it's a very interesting business, especially for everyone in this room. The abstract is, massive amounts of data can now be available to deliver insights to help protect servers against malicious attacks. This, of course, requires this data be properly collected, channeled, and analyzed. In this session, Igor is going to explain the real-world use cases of how big data is being applied to security to help protect against wide types of attacks on your servers. Please, a big CloudFest welcome for Igor Seletsky. Igor, come and join me on stage.
Hello everyone, how are you? It's my 8th year here at CloudFest, and I always love to give talks, I always love to meet so many people, it's always nice. But this year I actually have sore throat, so if I lose my speech during this talk, I'll just continue doing it in sign language. Anyway, so about a year ago we started to sell our new product, Immunify 360, which is a security product that collects lots and lots of data. It collects it, analyzes it, and feeds back the servers participating in it with the information of who should be blocked, who shouldn't be blocked. And now we have thousands of servers, and we see quite a lot of data. So this is a bit old slide. We're actually seeing about 10 million security-related events every day. It takes a lot of space. We had to figure out how to deal with all this data, how to correlate this data, how to analyze this data, what to do with it, and that's what I want to talk about today. So our cluster is actually fairly simple installation of Spark with HDFS, etc., etc. We started small, right now it's still not too big, terabyte of RAM, hundreds of cores. We moved to 3 replicas for HDFS, it's going to 6, and the reason is that once you're getting that much data, it really takes a lot of CPU to analyze this data, to understand this data, to correlate this data, to find patterns in the data, to find anomalies, etc., etc., etc. That's what we did, and to be honest, it took us inordinate amount of time. I think we released the software thinking that we're ready. Then we had so much interest in the software that our system actually crashed and we couldn't process it for days. We had to order more servers. We have to get more processing power to be scalable to get that data. We got about 10 times more servers than we expected at first. But today we're running well and can process the data. So what do we see? What do we see in sense of security accidents? So Immunify 360 has many parts, but the main part is web application firewall and intrusion detection system that monitors all the requests that are coming in for HTTP. It monitors the logs, so it sees when someone is trying to log in as SSH, as FTP, as mail client, etc., etc. It sees it, it sends it to us. We see who else using this IP or this request is trying to do something similar. And what we see is that majority of attacks are going against WordPress. That's the #1 attacks that we're seeing, followed very closely by mail. And it's kind of interesting. So for WordPress, there is 2 types of attacks, and I'll go into it more details. For mail, there is just one thing that we see is someone trying to brute force the password. And brute force overall is majority of your traffic. Then it's followed by SSH, FTP, CMS, etc., etc. But brute force is what we see the most. After that, we see exploits. So people still attack WordPress the most. That's where you see. They attack it using probably 100 different attacks, maybe more. But it's not the only thing that's being attacked. We see other things as well. Most of the attacks are dumb. They don't care if you run WordPress or not. They will still try to access your WordPress installation with those exploits. It's kind of funny to see. But it's small. It's not as big. It's probably about 2 or 3% of what we see in terms of brute force traffic. And if we would talk in terms of amount of IPs, we see 60,000. So every day we block 60,000 IPs or so. This number kind of grew as we had more customers, and it will continue to grow as we have more and more customers. But on our customer systems, we see 60,000 IPs attacking them day to day. And out of those 60,000 IPs, 20,000 IPs will rotate. But of that, the patterns are very different depending on the attack. So if you have mailboxes being cracked, it's actually subnets. It's lots of subnets simply trying to brute force mailboxes. And I don't know if you know, but the reason they are trying to crack your mailboxes is not to send spam. That's no longer #1 reason hackers are getting into mailboxes of your customers. They're actually reading the mail. They love to read mail, probably more than your customers. So what they're getting from that mails is anything like bank statements, logins and passwords to other accounts, like to World of Warcraft or Facebook, anything like that. They don't care. They can monetize it all. Any personal information can be monetized. Any login information to social networks can be monetized. Logins to other accounts can be monetized. That's what they do. That's why they love mailboxes. So quite often, you will have mailboxes brute forced. They can log in it, and you will not see a single email sent from that mailbox for months, even for 6 months or a year. Only once they know that there is nothing to gain from that mailbox anymore, they might start sending spam from it. And even then, the patterns that we notice is that spam goes out very rare. What you will see is that some mailboxes will send maybe 1 or 2 spam messages every month. And you will never see that because there is no abuse, nothing reporting on that. They just have so many accounts that they can allow it. So that's for mailboxes. It's mostly subnets that's attacking the mailboxes. For WordPress, it's everything. Everything and anything. There is subnets that attack mailboxes. There is a hacked DHCP accounts. There is VPN accounts, anonymous proxies, store nodes. We see absolutely anything attacking WordPress. Exploits is somewhat mixed. We've seen only one subnet that just does exploits. Everything else is very much distributed. Exploits is actually what uses Tor nodes the most. It was quite interesting to see. And just in case, regarding IPs, so one interesting thing is that about half of the IPs change their profile in about 5 days. So there is this whole set of subnets that don't change, but anything else typically changes within 5 days. So today this IP is attacking you, in 5 days it will stop. Not always, I understand, but that's what we often see. So you cannot just block IP forever. You actually have to monitor if that IP is still good or it's continuing to be bad. Something that was good a few days ago can be bad today. It's something that you can have to actually monitor. Now, because we're growing so much with the number of servers and we're growing quite fast, we are protecting more than 1 million domains today, we are seeing a lot of those traffic coming in, and we can analyze much more than before. So if you would compare the number of attacks that we stopped today versus what we did 12 months ago, it's about 1 to 50. So we stopped 50 times more attacks today. And this is just something I found interesting, a list of subnets. It's an actual subnet. So you can take a picture of this slide and add it to your firewall. It's by far not more of them. The whole list is about 120 of Class C subnets that are just doing exploits. They're not doing anything else. So just few of them are doing WordPress. Most of them are doing, they're just brute forcing your mail accounts. So typically, when we block some IP, we don't block it permanently, or we don't really block it. We actually show customer a Captcha. So if it's a human, they can bypass the Captcha just by clicking checkbox, and they're done. But we can see who actually came and clicked on the Captcha or tried to come to the Captcha and do something or not. So not a single IP from those subnets have ever tried to pass the Captcha. Never. Everything else did, but these subnets, they don't rotate, they don't change, they just brute force accounts, which means we're really not doing a good job of spotting those things and stopping those things. Otherwise, they would not be profitable and would not exist. So the second type, we had brute force attackers, we have exploit hunters. Now, with exploit hunters, it's much more interesting picture because they're not as dumb as just testing a lot of passwords all the time. What we see is that they are attacking for specific vulnerability. So you can actually assign that this IP does this particular CV and that particular CV and that particular CV, and it does just like, does only them. There is those that are much more general, and they are running some kind of SQL injections that we cannot even identify what they're doing. We cannot identify what software they're hacking. It seems like they have some kind of type of security scanner that is willing to hack whatever it can hack. It's clearly botnet. It's not a nice people that attack a lot of different sites, but they are doing generic scans and they will hack into any software. Most of those exploit hunters, they are dumb. They don't check if you have software. They will first attack, and then based on the reply, do next attack or not. But the first attack doesn't rely on the fact that you actually run the software. Some do prior to actually attacking, check if you have the software, check if you have the right version of the software, etc. That's rare. But what is even more interesting is the attackers that impersonate humans. So they will actually make it look like they did browse the sites. They will have the same user agent in the headers as the regular users. They have pauses between requests of a minute or two. So if you just look at their traffic, you will see a regular user going unless you know what to look for. Of course, for us, we're seeing the same patterns on hundreds of servers, and we realize it's a botnet. It's not a human. No human would go to 100 WordPress sites and do the same thing on all of them. But if you're looking from one WordPress site perspective, you will not spot them. They look just like humans. Another thing we analyzed, so we have web application firewall with rules. It's your typical mod security firewall. We just have significantly more rules than anyone else because we don't block on those rules. We send the information that this rules catch, we send it to us, and then we analyze how it correlates with what other people see. And what we realize that no matter what vendor of mod security you use, they don't have good rules. No one has it. So either rule is too specific and doesn't catch majority of the thing, or it's too generic and catches too much of a good thing. There is nothing in between. We haven't seen anything that catches a lot of bad guys. Some rules from third-party vendors are terrible. It's just funny how terrible they are. They just only block good guys and never block bad guys. And typically it's something like Cold Fusion or PHP 5.2.13 bugs that they are covering, something old, but it's still part of their mod security rule set that your customers would trip up on, that would block, but it serves absolutely no purpose because no botnet will ever be stopped by that, and most likely you don't run that software. And that's why we had to come up with this generic rule set that catches a lot of wrong stuff, but because we can correlate it on the back end, we only block the good stuff. Now, so as I was saying, we don't actually block it first, we show Captcha. And we let human to click the button and continue. And we thought it was a good defense against botnets. When we started, only about 0.1% of the botnets would go through the Captcha. It was low enough for us not to be worried about, etc. Today it's 5%. 5% of botnets can easily bypass Google Captcha or any other Captcha. They're using a bunch of services, something like anticaptcha.com. So for 50 cents, they can pass 1,000 captchas. It's cheap. It's very nice for them. So Captcha is stopping being something that stops bots. Today we see 5%. We expect in a year it's to be 30%, and probably in 3 years, either Captcha has to change or it's no longer reliable. We'll also see that JavaScript is no longer stopping botnets. They're using Selenium, they're using Phantom.js, they're using whatever they're using, but proof of work doesn't work, JavaScript doesn't work. They're adapting as fast as we're adapting. It's really something to fight. It's an arm race. We're part of this arm race. What was even more interesting is that good bots, the non-malicious bots, are also using the same techniques to bypass those captchas and blocks. So Hrefs is a SEO bot. They just go and scan the internet for their SEO purposes. There is absolutely nothing malicious that they do. It's a big company, etc. And we knew that we're blocking sometimes some of them because some of their IPs are not listed on their websites, but we still know it's them because of reverse DNS, etc. And in middle of February, we see them passing Captcha. Before they didn't. Now, today, they will pass Captcha like it's nothing. So it's interesting how Captcha no longer that efficient. Another thing we see is that you can no longer, well, you could never just block the IP, but blocking IP by itself is not something that you want to do. Because what happens is that a lot of attacks are coming behind the routers, behind the net routers from home, from infected home computers. And you typically have 4, 5, 6, 7 devices at home, and only one of them infected, or maybe 2 of them infected. And they start to attack a bunch of computers on the internet, a bunch of other servers, like brute force WordPresses. And when we would block them everywhere, we would see that there is still good patterns, good human natural browsing patterns that are going through to some other sites, not the same sites that are going that are brute forced from the same IPs. So today you actually have to separate not just IP addresses, but actual computers behind the IP addresses and block only the bad part, not the good part. It's not that difficult once you have enough information. What also helps is that typically bad guys are going to a different servers, like from the same IPs, they're going to a different sites, different servers than actual humans behind this IP as well. So that helps a lot in filtering. And of course, to make sense of all this data, it's not enough to look. You really cannot look at 10 million records. And even if you dumb it down and filter it out to say 50,000 records, it's still impossible to go through 50,000 records and find patterns every day. So we employ a lot of feedback loops with captchas, etc., that is being fed through machine learning algorithms, and we look for trends, we look for anomalies, we look for that stage, for all those things. But even that is not enough, so now we're building components that will sit on a client and provide machine learning analysis for bad stuff on your machines. And part of it is because we're not sending all the data to us, especially with GDPR, etc. We cannot send all the data to us, but we want to get the analysis of the data because it gives us a lot of understanding of what needs to be done, and that's what we're working on. We're working to perfect this protection for NAT so that we're blocking more of a bad guys, less of a good guys. We're working on the whole technology called Web Shield, this first front-facing framework that will not use just a single way to stop the hackers, but a combination of them, because no single stuff will stop them. They will circumvent anything and everything. We just have to make it extremely expensive for them to do that. Today, it costs them, what, 50 cents per 1,000 captchas to pass. We want to make sure it costs them $5 per site to pass. And that's what we're doing. Thank you very much. Do you have any questions?
Igor, thank you so much. I can see a question over here. Yes, if we can have a microphone go over there. One of our athletic microphone ladies will take it over to the question.
No microphone?
I've lost where the question was. Stand up. Here comes the microphone. Gentleman there.
I have a timer ticking. 40 seconds.
Time's up. Sorry. No, that's up.
You said the captchas are getting less and less effective. What are you using, or I guess what are you planning to use instead of captchas, or what?
Yeah. So Captcha is less effective. So it went like from 0.1 to 5% of blocks are being passed, and it's going to be more. It's completely obvious. So we're going to do combination, and we're doing that already in some form of proof of work, proof of JavaScript, and passive agent fingerprinting. So for example, there is some things that are very hard to fake, like size of TCP window, and we know that particular user agent should match this particular size of the agent of the TCP windows, and there is about 10 or 15 different parameters that we will look like that to passively fingerprint particular user agent, and if they mismatch, we know it's not a good Captcha passer, and we should still block them.
Thank you.
Great.
I think that's it. My time is up.
Igor, thank you. Before you leave, where can they find you to talk to you? Where is your booth?
We're at booth B04. Look for the Guardians. It's the coolest booth we ever had. I think we outdid ourselves. So please stop by just to take a picture with that absolutely amazing booth.
Igor Seletsky, thank you so much.
Thank you very much.
Great presentation. The CEO and co-founder of Cloudlinux.